If we see this three-dimensional model that I have created before for the clubhouse, we see that there are different heights of walls. We are working on this north area, which has the same height for all the walls. We can also look at those details if we look at the elevations. The elevations that we have seen before, we know that there are different heights for the walls. As we can see in the north elevation, this north area is slightly lower than the central corridor, which is lower than the main entrance of the building. So that indication that shows that we will need to create different conditions for the walls that are on the low height, medium height, and high height. So we will need to have conditions for each one of those different types. Let's go ahead and start with the plan layout. I sort of like to use the A22 because this one has additional details that are not shown on A21. So let's go ahead and get started with the men's locker room. We go to drawing A51 and we can see A51 detail 1 is going to show us what is the height of the wall inside this section. So we have this is kind of interesting to note. We have the suspended ceiling is at 8 feet 6 inches, right? And then we see that the interior 5/8 gypsum wallboard goes all the way from the floor to the top of the roof. It goes past the suspended ceiling all the way to the top. And that means that we will have paint only to 8 feet 6 inches, but when we estimate the area for the wall board, we have to go all the way to the top. So we will have to make a distinction between the height that's going to be painted and the height of the entire wall. So here we have the this wall is going to be perhaps even a little tricky to estimate because the section on top of the concrete beam is going to be triangular. So that section is going to have different height as we run the length of the wall. So for this particular case, we may need to create two conditions. One is going to be our regular linear condition to estimate the length of the wall that we're going to use to count the number of furring strips that we need on this wall, and then also the area for the wallboard. But that area of the wallboard will stop at the top of the concrete beam. And then we may need to go to the elevations and use the elevations to create an area condition that is going to account for the area that goes on top of this beam, which is the triangle that shows on this section. So that's one way to do it. Of course, there are many different ways to estimate this kind of work, but we have to choose one way to do it. Another possibility is for this particular wall. What we can do is to use a height that is the top of the beam plus 1/2 of the elevation for this roof. So that's going to take into consideration a half of a rectangle that covers this area, which then will result in the area that we want to estimate. So as you can see, there are different ways to do this. I am going to use one triangular area and one linear condition to estimate these sections. So we'll go to the schedule then. I will go and look at a couple of drawings. I am going to see first the roof detail, which is S3, and I am going to identify the beams that we have on this section, which is the TV1 and the TV rake. So TV1 is a beam that has elevation of 9 feet. Has a 9 feet elevation. So we can then start with our first wall, assuming a 9 feet elevation for that beam. So let's go again 5-1 and say if we have a 9 feet elevation up here, right? It's going to be 9 feet elevation for the top of the beam, and then we have 8 feet 6 inches inside for the suspended ceiling. So I will use the first interior wall with 1-inch metal furring. Okay, this is the wall that we have right now, and basically what I am going to do is I'm going to open this this condition, and I am going to set it for 9 feet tall. So I am going to make in the note the wall is 9 feet tall, and the suspended ceiling stops at 8 feet 6 inches. Really, the difference is not too much, so some estimators may want to assume the paint goes all the way to the same 9 feet, and then just consider this small portion as part of the waste. So then the waste factor will be slightly smaller. Instead of using maybe a 5 or 8% waste factor, they may be using 3% because they're including that small section. That it depends really on the estimator. So let's go back to our drawing, the plan layout drawing A22, and we're going to make sure that we have the area as unassigned, because if not, if we have it in a typical area, we will be counting these sections several times. So with we're going to estimate the interior walls with 1-inch metal furring, 9 feet tall. The height of the wall is then 9 feet. The thickness, we can set it to 1 if we want, or we can leave it at 4. This is really going to be 1. Although sometimes people tend to use a thicker value because we have the 1-inch furring, and then we have also the 5/8 for the drywall. So basically what we will do is we'll follow the interior perimeter here, because this wall is going to go on the interior side. And then we have the women's locker room, which has the same type of finish, and we will follow that contour up to this point. Now this wall has interior exterior wall, but this has piping behind it. So this has the thicker area. This is going to have the 6-inch metal furring, or the 3 and 5/8, depending on what the architect says. Because it has piping, we are going to use the 6-inch. So let's look at this drawing real quick here. The detail A512. We will just zoom in this section, and then we see in this section that again we have the 9 feet height, and then we have um, the detail for the metal furring. It does has here 3/5/8 metal studs with R 3.8 insulation on 8-inch CMU or concrete typical. So despite that they said 6 inches in some of the drawings, they're using 3 and 5/8. So we'll use 3 and 5/8. So this will be exterior interior wall with tiles. This one here. This has 3/8 metal furring at 16 inches on center with 5/8 cement board. Perfect. And these are 9 feet tall. So we enter the height as 9 feet. And then we set the thickness to 4 because we have 3/8 plus the drywall, so that's going to be almost 4 inches. And then we just follow this contour here up the way to the end, and that wall is then going to have the 3 and 5/8 thickness, and the gypsum board. Something does not seem quite right here with the scale, maybe 1/4. Yeah, the scale doesn't seem right. The reason I noticed that the scale is not right is because when I draw the 4-inch line, it does not seem to match the architect 4-inch line. Of course, what I should have done is to verify the dimensions on vertical and horizontal scale, so I would have noticed that my scale is off. So now that I realize that problem is solved by changing the scale to the correct scale. So this will be 1/4 of an inch to a foot. And now see, the thickness of that wall seems more in line with what the architect has on the drawing. So now I do trust this scale. We can continue on the walls. Now this center brush up area, this brush up area has a higher wall. Let's go 8 1 detail 2, A8 1 detail 2. We notice that this is the again the 1 inch furring. As we have seen before with the brush up, this is the 1-inch metal furring at 16 inches on center, exterior interior wall. So that's the same as we had over here, but now the height of the wall is different. So let's look at the uh, roof structure S3, and then now we're talking about this section that has TB3. So TB3 is at 11 feet. So these walls are 11 feet high. We'll go back to our drawing. And then this one, I'm going to duplicate this condition. And no, this is not the one I want to duplicate. I want to duplicate. So I'm going to do a undo here to remove the wall that I'm going to duplicate the exterior wall with yeah, this is the one I want. The exterior walls with 1 inch metal furring, 9 inch tall. This is going to be now 11 feet tall. So I'm going to change 9 to 11. 1 inch metal furring. This will be furring. In interior at 16 inches on center. The wall is 11 feet tall. And the suspended ceiling here stops at 8 feet 6 inches. I'm not sure if that is the case. We have to look at the pro shop schedule and see what is the type of finish that that pro shop has. It may have the gypsum board finish rather than suspended ceiling. So let's look at the A9 A92, I believe, is where we have the finishes. And let's look at the brush shop. Brush shop is here. The walls are gypsum board painted, and the ceiling, it is acoustical tile. So it has acoustical tile on the ceiling. That's so we can leave that on the condition. Now we need to find what height does that acoustical ceiling ends. A212, A81, detail 2. It doesn't show the top. Here's another trick on navigation of the software. If you click on the black buttons next to the pages, it'll take you to the previous page or to the next page. But then if you click on this green button, it takes you back to the last page that you had opened, which in this case was the plan layout. So this is sometimes very convenient because it allows you to navigate to the previous page right away. So if we want to see how high the room is on the pro shop, we may need to then look at one of the cross sections. So let's see if we have a cross section running in A21. I think we do. We have a cross section right through the pro shop. Well, no. There is one on the women's locker room, and there is one here. Well, there is a transversal one, a 41 detail A gives you that cross section. So A41A should show the cross section across the pro shop. So here we have acoustical ceiling. Here we see the difference in height for the walls. So we went from 9 feet to 11 feet, and the suspended ceiling is still at the same height as the suspended ceiling in the men's locker room. So that remains at 8.6. That's the height of the suspended ceiling, even inside the main area of the building. So if we go back now to A21, we can continue our takeoff from the walls here in A22. We will continue our takeoff for exterior walls here, and this is going to be the interior wall with 1 inch metal furring, 11 feet tall. That goes from this point on, and it basically follows the contour of these walls here and I'm going to stop at this point. Now I'm going to switch back again to these interior walls that we have here. We need to now estimate these interior walls. So this is a interior to interior wall, and then we have interior partition, which is it seems like 4 inches wide. So we need to look at the details for these walls. We have women's locker room. That detail can be shown in A71, where we have the details from the women's locker toilet room to the women's locker room is shown on this detail. So we have this is 31, so this is going to show just the door section. If we want to see the wall section, we need to click on these details 16, 15. We have the we have the we have the 5/8 cement board with insulation and tiles on one side. So this is going to be an interior wall with tiles. This one here, that's what we're going to be using, and the height for this wall is going to be 9 feet. So I can type in here, this is going to be 9 feet. Click OK, and then basically we will follow just this direction here, and that's the wall that we are estimating. Then we have interior tiles to the corridor. This should be a thicker wall, but because we didn't find anywhere where 6-inch spec is, we're just going to follow this with 3 5/8. This is going to have tiles on one side and regular drywall on the other one. So we just follow these walls here. These sections here are this section here is the one where we saw that has double studs. So we will need a new condition for that, and this has a tiles on both sides. So this will be this same one, but with tiles on both sides. Same 9 feet tall. So we could duplicate this one here, and then we can just type with tiles on both sides. 9 feet tall. So we set this to 9 feet. Apply and OK. And then basically we measure this here. This is going to be with tiles on both sides also, but this one is going to have double reinforcement. So both sides, double studs. So this has metal fairings at 20 inches on center, metal fairing double at 20 inches on center, and then ceramic tiles on both sides, 9 feet high. That's the one. So we measure this wall here. Now we have this is the procedure to estimate the length and areas for these walls. So far, all of these conditions only have the areas. So we have set quantity 1 length, And I didn't on purpose estimated the areas because some of these areas we need only one side, some of these areas we need both sides. For example, this internal wall here, we are doing the interior finishes, right? So we want to estimate the area of the drywall. The drywall was on the interior side of the wall. The exterior side of the wall has brick veneer. So I could set up quantity 2 to be surface area single side. That way I will estimate the area of this wall all along that requires drywall on one side. Then this particular wall in here, it's a little bit tricky in terms of the finish because we do need to have the backing on both sides, but one side of the finish is the tiles, and on the other side the finish is paint. So we may not want to have double two sides at the same time. We may only want to estimate one side. So for this particular wall, I'm going to set quantity 2 to the area, surface area, single side. So that means I am going to estimate only the side that needs tiles. Then this wall in here has tiles on both sides, so I would like to take the quantity 2 as a surface area both sides. So now it's going to estimate at once the area of tiles that I need on this side of the wall and the area of tiles that I need on this side of the wall. Same is true for this wall in here. That's going to have tiles on both sides, so the area is going to be surface area both sides. And that's how I will estimate the areas and length for these walls. The last step that I need in order to estimate the number of studs is to use the count condition. I have interior corners that I need to count. So again, I will have to duplicate this condition, and I have interior corners for 9 feet walls, and then I am going to have interior corners for 11 feet walls. So now I can basically do a estimate, basically a straight count of corners for 9 feet walls or 11 feet walls. So let's take the 9 feet walls first. These are, we have one here, we have one here, we have one here. So on those corners we need to have additional studs. We have a corner here, we have an opening in this point, we have a corner in here, we have a corner in here, but this corner is not 9, this corner is 11. So I am going to delete that corner and use the 11 feet wall for this corner here and this corner here. So we have the corners, and then I made a mistake here. This is not. Okay, I made a mistake here and I placed this opening in the interior corners count. So let me delete that and actually use opening and intersections. I am going to duplicate this condition again. So I'm going to have openings and intersections uh, for 9 feet walls. And then I have openings and intersections for 11 feet walls. Okay, so this is going to be an opening for 9 feet wall. I have one here, I have one here. Of course, I haven't done the takeoff of these walls here. I will leave that exercise to you. Right now, this is just a example of how would you perform a estimate for linear measurements and areas using the conditions. In the next video, we'll go to Excel and estimate the actual numbers of studs.